Hi everybody, welcome to my workbench again. It's been a while when I was on the net, but again I'm back, so hopefully we can carry on. I decided to go on the power set, the Whaddon version 7, so you can see in front of you how far I got. Let me get that box out of it. The crystals are in there, so anyway, I'll put it up here. I'm fabricating our power supply, and the only power supply I will have is the battery. It's 12 volts, so I will operate it from there. And yeah, you can see what I have done, so there's not much to report actually, so I will shut down the camera and then proceed to the rest, okay? Have a look. Okay, alright guys, you can see in front of you our newly formed transformer. So where the multi-vibrator is going to get on, and this is on the power side from the valve, okay? This is our filament, so it's quite easy. Then I put my socket for my valve, rectifying valve, put on there already, and on the bottom I have a choke. Is that on there already? So this is the board, what fits on the left hand side, so I will screw that on here. So I put that on here, and then we have here our power transistors for our multi-vibrator. So and as you can see, there's cooling. I expect about 2.5–3 amps. I think with double up in 3055, the heat will be will be warm but not hot, if you know what I mean. These are the two driver transistors for those two power transistors. And we have here our resistors, power resistors, 10 watts. And we need all those to connect those up. And then we have our little board here where I'm going to put on my multi-vibrator on. And I will fit that on the back here, like that, something like that, or the other way around, that doesn't really matter. And then we have another board where I'm going to fit in here, in between, where those two power transistors are on. They are capable of 3.5 amps, so I expect 1 amp for the base of that transistor, 3055. 55 is that, 3055, yeah. Okay, that those they will be hardly warm, so I think about 800 milliamps, and they're 3.5 amps, so there will be no warmth whatsoever. Only those here, because of their resistance, they get hot, that's all. So that's so far as I got, so hopefully it is a bit clear to you what I'm going to do. So I'm going to fit this frame here on with those power transistors on there, sorry guys. And other stuff. There will be another coil underneath here. There's a sort of filter for the hash filter. Will be on there underneath as well, so and there will be some high frequency RF coils on here. I have not the sections from it. I bought, I'll just have a look while I've running. There you go. They are 4.5 millihenries. There they are. And I will put them in parallel and in series with some capacitors, and that will finish the hash off as well for the high voltage. So hopefully, I think it will take me about a week to build this all up. So I'll do it on my on my easiest way, so take my time, and not gonna rush this. I have my wife in the hospital, that worries me too, you know, and well, my mind was completely somewhat different than actually on this stuff. So she said to me, well, you should start it off again. So and she's ever so sweet. She's a very sweet girl. Well, if you love somebody, and now you know, what can I say? Anyway, guys, I'm going to continue this, and hopefully you like the video and give me a thumbs up when you like it. And yeah, there you go. So, by the way, I tested the other power set, the Olga, and I made the hash filter in there as well, and so on and so on. I bought myself a battery, 12 volts, 17 amps, so that will it gives me about 2.5 hour of operational time. I don't want to be carrying a very big battery. Obviously they are very heavy, and well, on the other hand, I shouldn't go above 11.8 volts, otherwise the filament voltage will be higher than 6.3 volts, so that has a disadvantage, that your valves are suffering, and they can fail at a certain point. Okay, guys? Well, this is so far so good. We'll come back to you and I have more. Okay, guys, now a bit further now. I'll show you what I've done. I made my multivibrator. See the little board with our 5 volts power transistors. I use them because of, well, it's more or less for safety. I don't trust smaller transistors, but only going to 50 milliamps. They can, well, something goes wrong, they will fail immediately, and those can have at least a half an amp, something like that. So I feel more safe with that. So I connect it all up. And you can see I put those 2 power transistors in there. So there we go, our resistors here. If I get them out, they will connect up on the collectors here, and that will be connected onto the base of those 2 transistors, and one on that side of the transistor. So and the collector side, will wire up with the transformer. I just dremeled the corners away here because I couldn't, I'll show you first, I couldn't fit that because I put it those hash filters in there. You can see them. Yeah, you need them, but I put another filter in here, so also with the hash, and there will be an electrolytic capacitor here, 10 microfarads, so that will be okay. See here the other choke is there. The only thing we have to do is that I dremel the corners away, so I can put on that transformer here, because it doesn't fit it anymore because of those bolts that are in there. So I dremeled them away. You can see it fits nicely together. So that should be okay. And then yeah, of course you have your valve in here. So what I will do next is get everything connected up with the valve concerns. I will connect the transformer up. What I not will do is connect those high voltage connectors onto the valve yet. So what I want to try first, see if the multivibrator works, and if it does, I will be able to light up that valve what goes in there. So this is the 6X5. The 6X5. That's that the little valve here. So he will light up when everything is okay. When that all is okay, then we have no high voltage on the end, because I will finish totally up underneath with all the wires. So connecting up, get that all together. Yeah, I have to screw that down on the board. Then I have to make a connection with one of the sockets here underneath. Here. That's got quite a bit of work still, but there again, see, I can fit that valve in here. So, see, come on then. There he goes. Yeah, you have to connect them up like that. So, we see if that lights up, and then that lights up, we connect those two up onto the valve, and then we have the high voltage straight on. So, then I have to fit this board with all the things on there, fit on the suitcase, in the suitcase, and connect those 3 wires up coming out of there. So then we can see if our power set will function. So that's in a nutshell what we're going to do. So there's quite some work to do. So you have to connect everything up here. That has to be done still. So this is the filament. So we have to see that. It will be okay, guys. So it will all work as expected. So you see there's quite a bit of work underneath here. I have to get a strip in here. Let's show you. Get it out. I'll put a strip in here like that. You see. I'll probably put another strip on that side as well. We'll connect that up first. When we get that in, then we get those soldered up and connect everything up as it should from our schematic. So yeah, well, how long it's going to take, I don't know. I really don't care actually. And that will be it, guys. So that's all I have to report. So you will be a witness of how that thing functions, and yeah, and then we can go up to in the field, take our battery with us, and we can make connection with somebody in the area or in England. Hey, England. That there comes something back here. So if you think about it, those people are risking their lives with those things. Well, it is an honor actually to build a power set like that. If you think about it, what the sacrifice those people brought for our freedom, then yeah, that says something. That it's quite memorable. That's also the reason why I build power sets, because I honor those people, and they did great service for everybody on this world. The only point is, guys, nobody seems to realize that anymore. See, they forgotten that important lesson that I brought. So, okay, guys, I will leave it at that, and I will come back to you when I have more, or actually able to test our friend here on the workbench. Okay, I'll see you then. Hello, everybody. Well, guys, you can see the finishing of the bottom part is the plus and the minus. There's the on the socket, and then we can screw it down. They also fitted the transistors on the back side. I'll show you that in a minute. So I'm going to solder that on and come back to you. Alright, everybody, you can see the socket where the whole thing will be connected to, and then I can show you the top part. I mounted it now on the board. Yeah, you see the connections of the transformer are fitted. The only I didn't do is those two. There's the anodes of the valve. We can show you the other part, the collectors of the power transistors for the transformer. Yeah, and then you can see the base resistors are on there. So And that is about it, guys. We are ready for testing now, so we're going to do that now and see what happens. But okay, we'll leave it at that. Should be okay. The only thing we need to do now is to get our capacitor on here still, to prevent that high voltage can develop over those two poles. So that would self-destruct the transformer. Where is my valve? I can put that valve in. Where is it? Oh, there. Put the valve in. These are the connections for our power set. So that is the filament, the ground, and the plus. That's all there is to it. Then we have here, we have our low voltage fuse, and here we have a high voltage fuse, 100 milliamps, and we have here a low voltage fuse from 5 amps. Okay, so we put our valve in. We put them in like that. There we go. Now that's all there is to it, guys. The next point is see if this valve will light up. If we put some voltage to it, and then it should be okay. Alright.